Concept 1. Problems based on Concept 1. Problems based on Wilson's theorem. Concept 1. Problems based on Wilson's theorem. All varieties under Wilson's theorem we will discuss straight from starting basic level question, intermediate level question, advanced level question. Side heading Wilson's theorem. Wilson's theorem. Wilson's theorem. Reminder 1. P minus 1 factorial plus 1 divided by P. Reminder 1. P minus 1 factorial plus 1 when divided by P. It is always 0 as long as P is a prime number. This is the theorem proposed by a famous scientist by name Wilson. Wilson's theorem is P minus 1 factorial plus 1 divided by P. The remainder is always 0. P minus 1 factorial plus 1 when divided by P. Remainder is always 0. Example. Listen carefully. I will cover 20 concepts by today, the last hour. Because if P is a prime number, if I take P equivalent to 3 minus 1 is 2 factorial, 2 factorial plus 1 divided by 3. 2 factorial is 2, 2 plus 1 is 3, 3 divided by 3, remainder 0. One more example which we will take. If P is 5, 5 minus 1 is 4 factorial plus 1 divided by 5. 4 factorial is 24, 24 plus 1 is 25, 25 divided by 5 is 0. Extremely important theorem in number system. P minus 1 factorial plus 1 divided by P. Remainder is always 0. P minus 1 factorial plus 1. P minus 1 factorial plus 1 when divided by P. Remainder is always 0 when P is a prime number. When P is a prime number, P minus 1 factorial plus 1 factorial plus 1 when divided by P, it is 0. It is when the P is a prime number. The first question a students might get a doubt. Anil sir, what if the denominator is a composite number? When the denominator is a composite number, we can use Euler theorem or a negative remainder or a Chinese remainder. Problem 1. As many problems as possible. Problem 1. First one. Remainder 1. Basic to high level we'll discuss 16 factorial plus divided by 17. 16 factorial divided by 17. 16 factorial can be written as 17 minus 1 factorial. Add 1 and subtract 1 divided by 17. Why are we adding plus 1 and minus 1? Because P minus 1 factorial plus 1 divided by P, it is 0. Negative remainder is minus 1. If you get a negative remainder, for example, 13 divided by 7. Students who are listening to the class for the first time, 13 when divided by 7. 7 ones are 7. Positive remainder is 6. Negative remainder is 7 twos are 14 minus 1. Negative remainder is minus 1. If it is minus 1, add it with the denominator to get the positive remainder. Add it with the denominator to get the positive remainder. If you get a negative remainder, if you want to convert to positive remainder, if there is a negative remainder, if you have to convert into positive remainder, add it with the denominator. Add it with the denominator. If wherever you find a negative remainder, add it with the denominator, automatically it will get converted into a positive remainder. For example, 13 divided by 7. 7 ones are 7. Positive remainder is 6. 7 twos are 14. Negative remainder is minus 1. Negative remainder minus 1. Add it with the denominator. If I add it with the denominator, 7 minus 1, 6. Similarly, I got minus 1. Minus 1 plus 17 is 16. What is the answer for this question? 16. No answers in the live chat. All you have to do is just I will teach you how to listen. No need to show your mathematical skills on my class. It's a time waster for you. It's a time waster for me. It's a time waster for all the other students. I will teach, just listen. That's all. P minus 1 factorial plus 1 divided by p. This entire value is 0. 0 minus 1 is minus 1. Negative remainder is minus 1. Positive remainder is 17 minus 1, 16. Answer is 16. One more question, then we will discuss the shortcut. Second one, reminder 1, 22 factorial. Very high quality questions we will discuss as we move forward. 22 factorial by 23. 23 is a prime number. Wilson's theorem is used when the numerator contains factorial and the denominator is a prime number. 23 minus 1 factorial plus 1 minus 1 divided by 23. So this is nothing but p minus 1 factorial plus 1 divided by p. It is a negative remainder minus 1. Answer remainder should always be positive. If you get a positive remainder, that itself is the answer. What if the remainder is negative? If it is negative, add it with the denominator. 23 minus 1 is 22. If you get a positive remainder, 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 that itself is the answer. No need to do all this. P minus 1 factorial divided by p. P minus 1 factorial divided by p. It is p minus 1 when p is a prime number. When p is a prime number. Please write down this. Until and unless I ask a question, right? Don't give the answer for the question. Nobody is interested. Right? P minus 1 factorial when divided by p is p minus 1 as long as p is a prime number. Very, very important property. This is the first conclusion of Wilson's theorem. P minus 1 factorial divided by p is p minus 1 when p is a prime number. When p is a prime number. Few examples. First example, Wilson's theorem is used when the denominator is a prime number. 72 factorial divided by 73. P minus 1 factorial by p is p minus 1. 73 minus 1 is 72. One more example. Not a single doubt you will get in my class. Just listen carefully. 30 factorial by 31. P minus 1 factorial by p is p minus 1. 31 minus 1 is 30. The first important model is if the denominator is a prime number, numerator if it is of the form factorial, I can use Wilson's theorem. Wilson's theorem is used when the denominator is a prime number. First conclusion is p minus 1 factorial by p is p minus 1 when p is a prime number. Second, I hope it is clear. First one, probably we will do close to 80 to 100 problems by the time the session got over. You can see reminder 1, 15 factorial divided by 17. 15 factorial divided by 17. Now please write down a note. Write down a note. Suppose if the question is numerator divided by denominator, numerator divided by denominator, there are two cases. One is numerator and denominator should be co-prime to each other. Numerator and denominator are co-prime to each other. Case 2, numerator and denominator are not co-prime to each other. Please write down these two. Numerator and denominator are not co-prime to each other. Not co-prime to each other. We are discussing all the cases under case 1. First we will discuss with case 1 based questions. Case 1 based questions. That means At the end of when we discuss all the cases, then you will come to know what happens if the numerator and denominator are not co-prime to each other. Case 1 based questions, that means numerator and denominator both are co-prime to each other. What do you mean by co-prime? Yesterday Ajay sir discussed in the class. Two numbers are said to be co-prime if their HCF is 1. Two numbers are said to be co-prime if their HCF is 1. Just listen to the same correct order. First, we will discuss when the denominator is a prime number. After some time, we will discuss what if the denominator is a composite number. So, this is the case where we are discussing. All the problems will be of the form numerator by denominator. At the end of the second or the third session, I will give you a table. Case 1 when the numerator and denominator are co-prime to each other. Case 2 when the numerator and denominator are not co-prime to each other. We are discussing all the cases under case 1. Case 2 is the derivative of case 1. Right? First question. 15 factorial by 17. Now listen carefully. 15 factorial by 17. Sujan Gowda, your impatience does not work in my class. Please listen carefully. Right? I'm observing you in the live chat. Don't keep on asking everything at the beginning of the class. I do not want any student to take me for granted because it's a free class. Right? I will discuss. All you have to do is just listen. Reminder 1. 15 factorial by 17. Method 1. Where the most of the students might do a mistake is they will multiply and divide by 16. 15 factorial into 16 by 17 into 16. This is a wrong method. Why it is a wrong method is reminder divide 7 divided by 2. 7 and 2 are co-primes. HCF of 7 comma 2 is 1. 2 3s are 6, remainder 1. If I multiply and divide 7 into 2 by 2 into 2. 14 divided by 4. 14 divided by 4. 4 3s are 12. What is the remainder? 2. Now if you see, when the numerator and denominator is co-prime, I got one answer. When they are not co-prime, I got a different answer. So if you are trying to make numerator and denominator not co-prime to each other, answer might change. That is the reason this method is a wrong method. Crystal clarity, not even a single doubt you will get in the class. If you listen to a problem by problem, you might be listening to the class for the first time, maybe right, but I am taking the same class from the last 14 years of experience, almost 250 batches experience I got. So when the numerator and denominator are co-prime to each other, right, don't try to make not co-prime to each other and try to use it. That's a wrong method. Method 2, which we will call it as a backtracking method. What is backtracking method? Let me discuss one by one. Backtracking method. For example, if the question is 15 factorial by 17, identify the unknown from the known value. We know that p minus 1 factorial by p, it is nothing but p minus 1. Already we know that 16 factorial is nothing but 16 into 15 factorial divided by 17 is 16, because in permutation and combination n factorial is nothing but n into n minus 1 factorial. N factorial is nothing but n into n minus 1 factorial. By looking at the question itself, we got the answer. 17 zeros are 0. Remainder is 16. 15 factorial by 17. I don't know the remainder. When I further divide, answer will not change. When I further divide, answer will not change. 16 into which number when divided by 17? I will get 16. 16 ones are 16. When you yesterday in Ajay sir's class, he has discussed that if you divide it individually and do the answer, then further divide, remainder will not change. 17 zeros are 0. It is 16. 15 factorial by 17. I don't know the remainder, so I will call it as x. When I further divided by 17, I will get the remainder 16. So x is nothing but 1. X is nothing but 1. But in the exam, kindly do not, this is a time waster for you. This backtracking textbook method, it's a time waster for you. If any student is sitting in my class, he or she will sit for only two reasons: absolutely shortcuts and conceptual clarity. They know that we do not teach any traditional methods. 16 factorial by 17 is 16. 16 factorial is 16 into 15 factorial by 17. Do not use this method. It's a time waster for you. It's a time waster for you. I hope you are all there with me. Method 3. Method 3. Method 1 is a complicated method of ordinary division. Method 1 is 15 factorial by 17. Find out 15 factorial. Find out 15 factorial and divide it by 17 and get the remainder. Right? This is a traditional method. No idiot will use this method. Method 3. Method 3 is nothing but p minus 2 factorial divided by p. It is nothing but 1. Method 3. As long as p is a prime number. As long as p is a prime number. Please write down this point. Right? Traditional method is find out the value of 15 factorial divided by 17. Method 2 is the backtracking method. Method 3 is the direct approach. This is nothing but the conclusion of Wilson's theorem. P minus 2 factorial divided by p is 1. P minus 2 factorial divided by p is 1. P minus 2 factorial divided by p is 1. P minus 1 factorial divided by p is p minus 1. So directly, this is a derived conclusion. P minus 2 factorial. P minus 2 factorial divided by p. P minus 2 factorial divided by p. It is nothing but 1 as long as p is a prime number. As long as p is a prime number. Few examples. Reminder 1. 17 factorial divided by 19. P minus 2 factorial divided by p is 1. Reminder 1. 39 factorial divided by 41. P minus 2 factorial by p is 1. Third one. Reminder 1. 11 factorial divided by 13 is 1. I hope it is clear, right, sir? So p minus 2 factorial. This is the concept. Ensure that you write down everything whatever I am saying in your notebook and a pen when you are listening to it so that it will be clear to you. P minus 2 factorial when divided by p is 1 when p is a prime number. As long as a denominator is a prime number and the numerator is in factorial, we can use Wilson's theorem. 11 factorial by 13. I hope it is clear. In concept 1, p minus 1 factorial divided by p is p minus 1. P minus 2 factorial divided by p is 1. It's a very beautiful question. Reminder 1. 35 factorial. Very high quality questions also I will discuss. Reminder 1. 35 factorial divided by 71. Reminder 1. 35 factorial divided by 71. Please put a star mark on this question. It's a high quality question. It's a high quality question. 35 factorial whole square divided by 71. First we will discuss when the denominator is a prime number. Then we will discuss when the denominator is a composite number, how to use a Chinese remainder theorem, how to use Euler theorem, how to find out power to the powers. Everything we will discuss. Now if you see reminder 1, p minus 2 factorial by p. 69 factorial divided by 71 is 1. Just now we discussed 69 factorial can be written as 1 into 2 into 3 and so on up to 34 into 35 into 36 and so on up to 69 divided by 71 is 1. 71 is 1. N factorial is nothing but the product of all natural numbers from n to 1. 69 factorial is 1, 2, 3 till 34 into 35 till 69 divided by 71. 1 into 2 into 3 till 35. These are nothing but 35 factorial. Are you all with me? Next, 36 divided by 71. 71 ones are 71. It is minus 35. 37 divided by 71. 71 ones are 71. Minus 34. 69 divided by 71, which is minus 2. When divided by 71, which is nothing but 1. Which is nothing but 1. I hope it is clear. We require 35 factorial. So 1 into 2 into 3 till 35. This is one part. I got 135 factorial. 36 divided by 71. 71 ones are 71. Negative remainder is minus 35. 37 divided by 71. 71 ones are 71. Negative remainder is minus 34. So we got this one. At the end of the class, you will understand the power of today's class, sir. Especially students who are looking for high quality questions, they will enjoy this class. 35 factorial into minus 35 minus 34 and so on up to minus 2 divided by 71, which is nothing but 1. So there are some negatives. How many negatives are there? From 2 to 35 negatives are there. From 2 to 7, how many numbers are there? The numbers are nothing but 6. 2 to 35, there are 34 negatives. 34 negatives multiplied will become positive. So it is 35 factorial whole square divided by 71. It is nothing but 1. It is nothing but 1. 35 factorial whole square divided by 71 is 1. It's a very, very good quality question. Kindly make a note of it. 35 factorial minus 2 minus 3 minus 4 till minus 35. Minus 2 minus 3 till minus 35 is total 34 numbers are there. 34 times negative is multiplied. If 34 times negative is multiplied, that will become positive. So positive will happen. 2 to 35 is nothing but 35 factorial. Right? Again, Sujan, you are asking me, what is that we discussed just 1 minute before? Reminder 1. P minus 2 factorial divided by P, which is nothing but 1. Right? I hope it is clear. 35 factorial divided by 71, it is 1. It's a very, very easy logic. Still, we will discuss. A lot of textbooks are giving a very wrong conclusion. So that is the reason. As many examples as possible, which we will discuss. 69 factorial by 71 is 1. 69 factorial is 1 into 2 into 3. 69 factorial is nothing but product of all the natural numbers from 1 to 69. 1 into 2 into 3 till 69. I hope it is clear. I will do one more question parallelly so that no student will get a doubt based upon the logic. No student will get the doubt based upon the logic. Next one. Please write down the next question. Next question. A student who is preparing for aptitude exams, if you listen carefully to my class, after the class, in no way your friends or your institute teachers, probably you will be ahead of them in terms of the concepts. Reminder 1. 8 factorial whole square divided by 17. One more question. There are no sheets in our class. I will keep Keep creating as many questions as possible, right? I can take close to 24 to 30 hours class on number system without any notebook or without any book. Those of you who are listening to me for the first time, I am an author of 11 mathematical books. 8 factorial whole square divided by 17 by using the previous concept. 15 factorial divided by 17 is 1. 15 p minus 2 factorial divided by 17. Same logic if I apply. 15 factorial is 1 into 2 into 3 till 8. 9 into 10 till 15 divided by 17 is 1. 1 into 2 into 3 till 8, which is nothing but 8 factorial. I hope it is clear, right? 2 into 3 till it is 8 factorial. 9 by 17. 17 ones are 17. Minus 8 minus 7 till minus 2 divided by 17, which is nothing but 1. These the generally 1 into 2 into 3 till 8 is 8 factorial. 9 by 17. 17 ones are 17 minus 8 minus 7. Now here these were most of the students will realize. 2 to 8 there are 7 numbers, 7 negatives is negative, so minus 8 factorial. Minus 8 factorial whole square divided by 17 is 1. If I multiply, answer is minus 1, or 17 minus 1 is 16. 17 minus 1 is 16. I hope it is clear. Again, I am repeating it. 8 factorial. Please observe these two questions. It is not always the answer will be 1. It all depends upon the denominator, whether it is a 6 into a prime number plus 1 or minus 1, or 6 into composite number plus 1 or minus 1. First step is 15 factorial divided by 17 is 1. 15 factorial is 1 into 2 into 3 till 15 when divided by 17 is 1. 1 into 2 into 3 till 8, which is nothing but 8 factorial. 9 divided by 17 is minus 8. 10 divided by 17 is minus 7. 15 divided by 17 is minus 2. Minus minus minus. From 2 to 8 there are 7 negatives are there. If I multiply 7 negatives, I will get a negative. Minus into 8 factorial whole square divided by 17 is 1. 8 factorial whole square divided by 17, which is nothing but minus 1. Negative remainder is minus 1. Positive remainder is 16. Positive remainder is 16. Not a single doubt in Wilson's theorem. You will get a doubt. Next one. Next one. Another question. Another variety. No textbook will have this kind of particular order. Another variety. 23 factorial by 17. 23 factorial by 17. 23 factorial is nothing but 23 into 22 into 21 and so on up to 3 into 2 into 1 divided by 17. Here 17 will be there. 17 into any number when divided by 17, remainder is 0. Remainder is 0. 23 factorial is 23 into 22 into 21. In this question, what is the root cause of the problem? Numerator is a multiple of denominator. Numerator is a multiple of denominator. Especially when I am taking the class, ensure that you attend it without fail, sir. Numerator is a multiple of denominator. Numerator is a multiple of denominator. One more example. 14 factorial divided by 11. 14 factorial contains 11, so the remainder is nothing but 0. When the numerator is a multiple of denominator, answer is nothing but 0. Answer is nothing but 0. When the numerator is a multiple of denominator, answer is nothing but 0. Next case. Next case, not even a single problem. You should miss it out, and in my class, not even a single minute should be wasted in discussing something other than about your success in competitive examination. Right? Your investment of time should be respected by me. My investment of time should also be respected by you. Another one. Another. We did only p minus 1 factorial, p minus 2 factorial. Let us do p minus 3 factorial. Another question. 16 factorial by 19. 16 factorial by 19. Another question. 16 factorial by 19. Method 1. Method 1. Listen carefully, sir. Method 1 is already we discussed p minus 2 factorial. P minus 2 factorial divided by p is nothing but 1. So we will use this as a point of reference. P is 19 here. 19 minus 2 is 17 factorial. 17 factorial divided by 19 is 1. 17 factorial is nothing but 17 into 16 factorial when divided by 19 is 1. 17 into 16 factorial divided by 19 is 1. 17 divided by 19, it is 17. 16 factorial divided by 19. I don't know the remainder. When I further divide, answer will not change. Answer will not change. Why it will not change? We'll take an example and we'll understand it. 9 into 7 divided by 2. 9 when divided by 2. 2 fours are 8, 1. 7 when divided by 2. It is 1. 1 if I further divide, will the remainder change? 1 divided by 2 is nothing but 2 zeros are 0. What is the remainder? 1. 17 factorial. We are using a powerful concept known as backtracking. This method is known as backtracking. I will use this method in Chinese remainder and Euler theorem based problems also. P minus 2 factorial divided by P is 1. 17 factorial divided by 19 is 1. 17 into 16 factorial divided by 19. 17 divided by 19. It is 17. 16 factorial divided by 19. I don't know, I called the remainder as x. When I further divide, answer will not change. That means 17x when divided by 19. I don't know the quotient, but I know the remainder as 1. Dividend is nothing but divisor into quotient plus remainder. What is the concept which I used here? Dividend is nothing but divisor into quotient plus remainder. This is the concept which I used here. So 17x is nothing but 19k is 17k plus 2k plus 1. 17k plus 2k plus 1. So this is nothing but divisible by 17. Divisible by 17. 2k plus 1 should be divisible by 17. You take any value, still the answer will be same. 2k plus 1 is 17. K is 8. If k is 8, this is nothing but 17x is nothing but 19 into 8 plus 1. So 17x is 153. X is nothing but 9. What is the answer for the question? Answer for the question is 9. Answer for the question is 9. Answer for the question is 9. Sir, why can't I take 51? Even if I take 51 beta, k will be 25. So 17x is nothing but 19 into 25 plus 1. 19 into 25 plus 1. If you calculate it, still you will get the same answer. Still you will get the answer. Answer you will get 26. 26, 26, 28 you will get it. 28 divided by 19. It is again 9. You can check it out. You can take any value. I hope it is clear, but take the lowest value. 2k plus 1 is 17. K value is 8. If k value is 8, substitute k value 8. 17x is 19 into 8 plus 1, which is 153. So x value is 9. X value is 9. This is a traditional method. Method 1 is the backtracking. Method 2, a 5-minute problem can be converted into a single minute. Not even single minute. It takes about 10-15 seconds if you know the concept. I hope it is clear.